formed by 3 or more segments. So there's the segments again, coming from the first section. So you just connect all those endpoints. The segments are called the sides, which I think that's what you're mostly familiar with. All of the sides. And then the endpoints that connect the two sides, those are called a vertex, and then plural form is called vertices. That's the plural form. So if you hear me say vertex or vertices, you know what I'm talking about. There's just a few examples of some polygons here. That one has 3 sides, 7 sides, 4 sides, and then lots of sides. So how many vertices, Tony, does the star have? 5. Thank you, Tony. I didn't know it's got like a little clone of Tony all over the room. Wow. Thank you, Miguel. 10 vertices. Okay, next time let the person that I pick answer. And yes, have the answer in your head, and then if you send it around, then you can blurt it out. Because I know that's just on the grind too. Blurt it out. Okay? So, be able to tell me how many vertices they have. That's real easy. Okay? Yeah. Polygons. This is this whole section. Okay? You guys still copy this slide? Nope. All right, here we go. These are not polygons. You don't have to write these down if you don't want to. They're just examples on not being a polygon. What do you see in 4 out of the 5 figures? Curve. Good. So anything that's curved is not a polygon. Okay. Some people think a circle is a polygon because it's a shape, I guess. But circle's not a polygon. This one is not a polygon because the sides do what? Cross or intersect. Okay, but you can consider it as 2 polygons, and they just share that vertex, right? So that's like, that's that. And that one's what? That's an angle. That's not closed. Okay. All right. Moving on. Boys. Okay. All right, polygon parts. So just to kind of put up to a picture, the side, obviously, the segment right there. Okay, this one has how many sides? How many sides does this have? 5. There's the vertex pointing at the corner of point. You're going to hear me say consecutive a lot. Okay, those are consecutive sides, meaning what's a simple word that means consecutive? In order, next to, touching, simultaneously. So lots of synonyms used for that. These are consecutive vertices. Okay, you'll have to know that term on the last problem example. Okay, this is important, so that's how I would highlight. You're gonna have to name the polygon. Okay, just like you had to name a bunch of things on the last unit. Okay, we haven't graded your test yet, but hopefully it's good. Like naming angles, sides, vertices, points. You can name a polygon also. So the way you name it is in consecutive order. So, for instance, it doesn't matter what letter you start with. Okay. So this one just started with A, and so you name it A, B, C, D, E. You just have to go in consecutive order. That's it. And sometimes they like to trick you, and they'll do this right here. They'll have, let's just say, a quadrilateral. Okay, and they'll say, name that polygon, and then you'll say quadrilateral A, B, C, D. That's incorrect because it doesn't go in order, right? So you would have to say A, B, what? B, C, C, or A, C, D, B. Okay, you gotta counterclockwise in consecutive order. Okay? So they like to trick you sometimes like that to see if you remember the geometry part. Okay? They know you know your ABCs, right? So they say, oh, ABCs. But sometimes they make them words too. Okay? Right? Okay? So make sure that you highlight that part right there. Make sure you know how to name it. Okay? Name it, meaning the points. Okay? Vertices need to be in consecutive order. No, just not just the letters. That's it. Okay. Yeah, we don't even really have to include that one right there. Okay, you don't have to take an hexagon to name it. You just have to put the points in order. Okay. Okay. You guys still copying that? The naming part especially. Alright, let's go there. Okay, this one, you don't have to write every name down because I know you know a lot of them. But I would write down the ones that you probably don't know. Okay? So, let's start off with the first one. This one, the keyword, let's highlight that part. And sometimes you just get confused when it says classify and name. Okay? So naming was the previous slide. Okay? Here's how you classify them. You classify them by special names. What's the special name for a three-sided polygon? Okay? This one I think y'all might say wrong. What's chord? Rectangle. Most of y'all said it right. Quadrilateral. Now, rectangle is a special quadrilateral. So we'll go over that either next section or one right after. Okay? Because there's a bunch of special quadrilaterals. I heard rectangle. What else? Square. Rhombus. Trapezoid. Starts with a K. What? Right? This one now. Like a snake or H.
Everyone's right. 50-50.
I would write that one down. Polygon.
That's the implementation of hexagon.
Why will I do this one and the other side? Okay, so bring this one down then for sure. Yeah. French class. So one plus something. That's what we do. So for 13 on down, they don't have special names for them. So you just do 13 gun, 20 gun, 50 gun, okay? And polygon has that style. In-gon represents a polygon for in number of sides. So all of these right here, we're talking, all of these right here are all in-gon. This angle right here has 4 sides, so A would equal 4. We would use this angle, okay? So incline represents any number of sides, okay? All right, moving on. Okay, so we're going to stay with the class so I can teach you how to be quiet. Okay, thank you. Diagonal. A line segment that connects two non-consecutive vertices of a polygon. So there's that word consecutive again. So be able to think of non-consecutive. So it's just a segment. That's it. So here's an example of a diagonal. That turquoise blue looks on. You can have more than one diagonal in some of the polygons. You can have 0 in the polygon. Okay, just depends on which one. Okay. Which one has 0 diagonals? The triangle. The triangle has 0 diagonals because do you ever have non-consecutive vertices? No. They're always going to be consecutive. There's only 3. Right? So here we can have 1, 2, 3, 4, 5 diagonals max, right? Okay. So we have one. In the next chapter, not next unit, next chapter, we're going to talk about the diagonals and how you can figure out the pattern here. Okay, question?
Do you have the easier for especially just for accessing stats and numbers? Why don't we just make it easier for everyone to follow reading on like
Because that's what the mathematicians back in the BC era decided. I just say easy because they're all, that's what they decided back then. Alright. Convex polygon. Okay, gotta know this term. It's a polygon that has no diagonals outside the polygon. And so some of your probably thinking, how would you draw diagonals outside the polygon? That's the next slide. Okay, so you can kind of just ponder and think about that. Here's some examples of some convex polygons. There's 4 examples. And then there's a bunch of purple diagonals drawn for you to see how they don't end up outside of this polygon. They're all in the inside. Okay, you'll see a picture on the next slide on how they can end up on the outside. You got it? Okay, so convex polygon. Sure. Concave is correct. And you have to draw all the features across one. Okay? The next one is concave. Okay? It's a polygon that you can draw at least one diagonal outside. So who can tell me what somebody thinks said it? Like a star is a concave polygon. Okay? So here's some other examples. This first one, okay, you can draw one diagonal if you connect that vertex to that vertex. See that right there? Okay? So the diagonal is outside of this polygon. Here you can draw 2 outside, one there and one there. I would also say maybe even from there to there, no, but it ends up staying inside, so that one doesn't count. But all you need is at least one. And then the star, you have a sun, right? Okay, so, yeah, so okay, another key word to think of when you distinguish this one from the other. This one has the word what inside of it? Cave. And so what does a cave look like in real life? right? So, if you think about it, this one came in right there. This one came in like that. That one there. Okay? So, if you can see a K on the polygon, it's concave. Yes. Correct. Good job. All right, everybody good with convex concave? Okay, moving on. Perimeter, you have to write this one down. You did this back in middle school, but be able to do that one. Okay, all you do with perimeter is. Okay, equilateral, equiangular, and regular. These all are kind of related. So equilateral polygons, they have all sides congruent. Okay. Equal angular polygons have all angles congruent, and you can see all the tick marks. So if you see those tick marks, that's signifying that they're congruent. Regular polygons signifies that it's equilateral and equiangular. Okay? So if I tell you to draw me a regular polygon, a regular octagon, a regular quadrilateral, which is what, by the way? Yeah, a regular anything. Okay, regular triangle. Be able to draw that. Maybe you can all the shapes. Okay. So y'all are talking that. Let me take the roll. Everybody good? Anybody feel lucky? Alright, here we go. Congruent polygons. So last time we talked about congruent what? You said what? Congruent angles, good. And congruent what? Segments. Lines. They're not really all congruent because what's the definition of congruent? Same size, same shape. Does the line have a size to it? No, it does not. Okay. All right. Okay, so if polygons are the exact same size and shape, kind of what you just said. Here's and y'all quit talking. Oh my God. Just stay after class. I'm going to show you what quiet time is all about. Corresponding sides and angles all have to be congruent in order. So if you have one angle that doesn't match with one angle over there, it ruins the whole thing. But everything else can be the same and it can look the same. Okay? But if they don't say or they don't have tick marks that say they're congruent, then they're not. Okay? So like this one, see all those tick marks? And this one here, see all those tick marks? They all match. Okay? For instance, C is congruent to what? S. Okay? C is congruent to S because it has 4 tick marks. Okay? Side ET is congruent to side what? EM. Okay? And then the way you have to name it has to be in order. So for instance, angle C was congruent to angle S. Notice that one came first. Well, then the S has to come first. Okay? A is congruent to I. M with T. T with E. If you write it out in order, which by the way on your homework and on your quiz, you're going gonna have a picture of some congruent whatevers, and you have to tell me what's congruent to what. Okay? If you put one letter out of order, then it's wrong. Okay? They all have to correspond correctly, just like I have highlighted right there. So make sure they correspond. Oh, again, they like to trick you, like, see how this has like a little stage to it, C-A-M-P, camp, S-I-T-E, site, campsite. Sometimes they will put them out of order on purpose to see if you're tricked and say, oh, this was a camp, that was this site. Campsite, campsite, to site. Okay? If they switch up the letters, you better still mark up what corresponds, okay? Don't let them trick you. Everybody got the gist of congruent polygons? Yep. All right, moving on. Okay, last one for the day. Okay, this is what you're going to do on your own right now, and then I'm going to show whoever is done with it first under the elbow. Okay, so you need to construct using your geometry tools. You need to create a pentagon with 2 consecutive side lengths of 4 centimeters and 3 consecutive angles that measure 100 degrees each. Okay? You don't need a compass. Okay? You do need a protractor and a ruler, but you can use the straight edge for the protractor one. Okay? Alright, so there's protractor right there you can borrow. Okay?